Hi grade 10, it's Miss D again. Today we're going to look at some logarithmic equations. Now we looked at some in the beginning of the unit, but they were quite simple. Today we're going to use some log equations where we're going to actually use our log laws as well. If we start off with a fairly simple example, we have log of x plus 9 equals log of 4x. Remember, if the bases are not written there, it's base 10, but you don't have to write it in. So these two logs are the same. So what we're taking the log of must be the same. So this is a simple equation because we can say, well, if they are equal, then it must mean that x plus 9 equals 4x. And now that's a super easy question. So now we just use our equation work. I subtract x from both sides. So I have 9 equals 3x. And then I divide both sides by 3. So x equals 3. So that was a really easy question. You should always do a quick check. This is very important with logarithms because sometimes your answer actually won't make sense. If I just do a quick check with 3, substitute it back in, and you must substitute to both sides. So 3 plus 9 is 12. Log of 12 is fine. You're allowed to take log of 12. 4 times 3 is 12, and of course we get log of 12 again. They are equal, that's why we get the same answer. But do not assume that your answer will always work. You'll see later on that we'll do an example where one of our solutions won't work. So this is very important. When I say it doesn't work, it means that you cannot take log of a negative number. The whole reason is because when you write a log as an exponential, then we know we can only take a log of a positive number. And so this is because when you rewrite it as an exponential, you never get a negative answer. So this is very important. I'll address this again in a moment. Okay, so a slightly different looking question because there's not a log on both sides. Now, if there's not a log on both sides, there's two ways that you can do it. The first way is to actually rewrite it as an exponential. So we have the base of the log is 3, and then remember we raise that to the power of the answer. So what I know is 3 to the power of 1, of course we don't need to write that 1 in, must be equal to what you take the log of, so minus 9x. And now it's just a simple equation that you know how to solve. So we divide both sides by minus 9, so we get x equals 3 over minus 9, which of course you should always simplify, so that's minus 1/3. Now if we do a quick check again, substitute minus 1/3 into our equation. Minus 9 times minus 1/3 is actually positive 3. And so log of 3 base 3 is okay. And we know that's right because we know 3 to the power of 1 has to be the same as this answer. Now the other way to do this question, if I do it quickly, is to make it so it becomes like this question over here. We rewrite it so we have a log on both sides. So the left-hand side is okay because it already has a log. But the right-hand side we need to rewrite. Now you must rewrite it though with the same base. It only works if the bases are the same. So I know I want log base 3, and then I need to take log of something. Now what I know is when the whole definition of a log is 3 to the power of, I want the answer to be 1. So I know here the log of what we take the log of is the answer. So I want it to be 3 because log 3 to the power of something gives me 3 to the power of 1. This is the answer. And basically that's a generalization that you can make while we're talking about that. In general, we can say log of a, base a, is always going to be equal to 1. Because if you rewrite that as an exponential, the base of the log is the base of the exponential, and the exponent is the answer. And of course, a to the 1 is equal to a. So you could use this rule in general. Now, once we have that, it works the same as what we've got over here, because we know we both have log base 3 on both sides, and so therefore we can say, well, minus 9x must equal 3, and then you just solve that equation, of course, to get minus 1/3. You just use one method, use the method that you like the most. I prefer writing it as an exponential, But of course, you can use this if this makes more sense to you. All right, let's look at a slightly different question because we have a minus this time. And this is where we need to use our log rules. The first thing you need to do, because we can see from the first question, as soon as we have a log equals a log, it's a really easy question then. So if we can rewrite this as log, as one log here. Now I'm subtracting two logs, so I can use my subtraction rule or the quotient rule. And I know that I just have log of x divided by 6, and that's equal to log 15. Remember they're base 10, but we don't have to write that. Now it becomes quite easy because log equals a log, so the x over 6 must be the same as 15. They must be equal. And then just using our easy equation rules, multiply by 6 on both sides, so I get x equals 90. Again, do a quick check. Log of 90, that's fine, so all is okay because we're not taking log of a negative number. Okay, question 4 is similar to question 3 in the sense that we need to use our log rules again. So again, we can see much easier if we have just one log on each side. So because they're being added, I know I can use my product log rule. And so this time I will multiply the two terms. So I have log of 2x, just using the log rule, and that equals log of 2. And again, they're the same bases. So if they're the same bases, it must mean that 2x has to be the same as 2. So 2x equals 2, and we can see that turns out to be quite an easy equation in the end. Divide both sides by 2, and we get 1. Quick check. Log of 1, that's okay, because log of 1 is 0. All right, so that's the fourth one done. Let me just move down to the last question. The last question is the hardest type of log equation that you'll get, and you'll see why in a minute. We start off the same as what we did in the previous examples. We try and write it as one log on each side. So here we have 2 logs. So they are being added together. That means that I multiplied the two terms. So I'll just write it as a product. Now be careful, you've got to have these in brackets because everything's being multiplied. And that equals log of 77. Now we need to expand this. So what I can say, before I expand it, again, we can do the easy step that what we take the log of, they must be the same. They have to be equal because they're both log of the same base. So it means this here has to be the same as that because this part and this part are the same. So now we just need to do some algebra work. So we need to expand this. So I'm going to have x times x is x squared, x times 3 is 3x, 7 times x is 7x, and 7 times 3 is 21, equals 77. Now this is where you need to be careful. We have an x squared, so as soon as you have an x squared in your equation, it's a quadratic. So when I solve quadratics, I know that it must always be equal to 0. Collect like terms, so I have 3x plus 7x is 10x. And what I'm going to do is bring that 77 over. So that's going to be minus 56 equals 0. So now you have a quadratic, so you have to use your knowledge of quadratics to solve this. So I put my 2 brackets. I know I need to have an x in each bracket to get that x squared. Then remember what we need. We need 2 numbers that multiply to give minus 56 and add to give positive 10. The first 2 numbers that pop into my head are 7 and 8. 7 eighths are 56. But 7 and 8 is not going to give me 10 in any way. I know that this is, because this is negative, one of them has to be positive and one of them has to be negative. And there's no way with 7 and 8 am I going to get positive 10. So I need to think of some other ones, some other factors of 56. The next one you might try is 2 and 28, but again, 2 and 28, there's no way that we're going to get any combination of positive 10. The next one then I would try is 4 and 14. So 4 times 14 also gives me 56. And the difference between 4 and 14 is 10, so that looks promising. So I need it to be add to give negative 10, so positive 10. So I know my numbers are 4 and 14. And so if the 4 is negative, because the 10 is big, the smaller one needs to be negative, and the positive one is the 14. Then I just solve my quadratic equations just like normal, so I can say x minus 4 must equal 0, or x plus 14 must equal 0. Solving that, I'm going to have x equals positive 4, or x equals negative 14. Now we need to check again, so I'll check with the 4. Up here, 4 plus 7 gives me 11, log of 11 is okay. 4 plus 3 is 7, so log of 7 is okay. They are both positive. Remember, you cannot take log of a negative number. If I check with the negative 14, hopefully you can see quite quickly I'm going to get a negative number here. Minus 14 plus 7 is minus 7. You cannot take log of negative 7. It just doesn't work. It's impossible. So what I can do, good idea to still write down 2 solutions to begin with, but then just cross the one that doesn't work out if there is one that doesn't work, to show that you have done a check. As I said, that's the